make those adjustments. Now that you have your data, you brought it back to your lab and you want to look at it. It's nice to have software that makes it easy to analyze the data. One of the capabilities that you want to look for is the ability to combine data from multiple sites on a single graph so you can compare what's happening. Another capability is now that you've got your data, sometimes you need to export it to other software packages to look for export capability. And it's also nice to be able to save your work as you go along. Sometimes you'll have a certain amount of data that you've captured and you've got it displayed in a certain way. It's nice to be able to save that, and then a month later when you get subsequent data, to be able to bring that data in and compare it on the same axis. So look for that capability as well. Another thing is, of course, cost. That's always a factor. The thing to keep in mind here is the cost of ownership is more than just the cost of the logger itself. If you can save time, or that's the way, basically saving money, time is money, or ways that you can extend the life of your logger. So here's some things to look for. Software that can compensate for drift with a couple of points can reduce the frequency at which you have to go into the field to take calibration readings, and so that can save you some time. Of course, the frequency that you need to go out into the field to take calibration readings is really going to be very dependent upon your site. If you've got a site that's got a lot of fouling, a harsher environment, you're going to need to go out there more often. So that's something you may have to experiment with for your site to see how often you have to go out there, clean the sensors, and take calibration readings. Another way of extending your sensor life is to make sure to clean it every time you're out there. So look for a sensor that's fairly easy to clean. That'll help extend the life of your sensor. At some point, though, your sensor may get fouled to the point where you can't clean it anymore, or your batteries may have worn out, used their useful life. So having the option to be able to replace your batteries and sensors can allow you to continue to use that logger. Another thing to look for is a waterproof data shuttle. It certainly is tragic if you drop the laptop into a stream when you're offloading data. That gets expensive real quick, to say nothing of the lost data. And I guess the good news is the cost of connectivity loggers is coming down. Some are below $700 now. In terms of mounting considerations, here's some things to think about as you're planning to go out into the field. First off, you want to choose a site that has a good flow of water, so you're getting water to the sensor. Another thing you want to be thinking about is how you're going to mount the loggers at your site. You want to make sure that the sensor is mounted such that any bubbles that form will naturally shed away from the sensor. So if the sensor has a vertical face on it, make sure that face is vertical so that the bubbles will drift away from the sensor. And also ensuring that the sensor is in a good flow of water will help reduce any bubbles that might form on that sensor as well. Another thing to keep in mind is it is a conductivity sensor, so we want to keep it away from metal. PVC pipe and zip ties are a great way for mounting conductivity loggers at your site. Here we've mounted a couple of conductivity loggers in a PVC pipe that has several holes drilled in it. The holes ensure a good flow of water to the sensor, and that the PVC pipe is mounted to a post with a couple of zip ties. So that works out pretty well. In preparation for going out into the field, you want to make sure that you have a good field meter to take your calibration readings out at the site, as well as cotton swabs for cleaning the sensor when you go out there. A typical field deployment will consist of, before you even leave your lab, calibrating your conductivity meter, so it's going to provide the most accurate readings. Typically do that with solutions that you keep back in the lab. So now that you've got your calibrated meter, you go out into the field, you take some calibrated readings at the site, then you pull up your logger, you offload the data, then you clean it, then you can relaunch the logger and put it back into your well or your PVC pipe, or however you're mounting it. Take another reading. It's always good to take a reading both at the end and the beginning of each deployment, and you're ready to go, and you can go on to your next deployment site and repeat that procedure. This is an example of our conductivity logger. This is the HOBO conductivity logger. It's designed for freshwater applications up to 10,000 microsiemens per centimeter. It has a Delrin housing, which is non-corrosive, very durable. It has a non-contact sensor there. The silver part that you can see is the sensor. It's fairly easy to clean. The logger has a optical interface that allows offloading the data logger even when it's wet. You can even offload this data logger underwater. It's so waterproof. It does have a waterproof shuttle that can be used for offloading the data. Makes it very easy to retrieve the data in the field. And the software is the HOBOware Pro software that supports the other HOBO data loggers. It provides drift compensation. It allows entering calibration points from the start and end of each deployment, and it offers a choice of conversion methods to specific conductance. And the price on that is just under $700. Well, at this point,
thanks so much, Paul. Now we're going to be opening up the discussion. If you have any questions, you can type them into the questions box provided on the webinar's navigation.